Well, I've done it again. I've left the hatch light on and the battery in my car is completely dead. I think it's about -11. This happened last night and I'm not sure what's going on, but I'm going to charge the battery with the solar panel. So I've taken the solar panel and I've connected it directly to the battery. No charge controller, no regulator, just the positive of the panel on the positive terminal and the negative of the panel on the negative terminal of the battery. And there's a reason for this. This is definitely the best thing to do if you're going to do a supervised recovery of your completely discharged battery in your car. And I'm using these clips to just hold the wires onto the terminals of the battery. So they're just mechanically connecting the wires on the terminals of the batteries. And I do have this voltage monitor device that I put together a few weeks ago that actually will provide some information about what's happening with the battery, but that's a separate discussion and a separate video right now, and it's not doing anything in this case. Right now it's just holding the wires onto the battery itself. So the next question we have is, how long do we have to charge this battery for? How long does this solar panel need to be connected? Well, that question's got two parts to the answer. First of all, let's think about how much current the starter motor uses, or how much energy the starter uses. If we say it's about 100 amps to crank the motor, and if we say we have to crank it for about 2 seconds, maybe, to start this engine, this is a modern fuel-injected engine, it starts really quickly, then we need about 200 amp seconds worth of discharge on the battery to start the motor, which also means we need to put in at least 200 amp seconds of energy from the solar panel, or charge from the solar panel. Since it's a 5 amp solar panel, to get 200 amp seconds, that means we need about 40 seconds of connectivity with that solar panel to get the energy required into the battery to then discharge to start the car. It's not very much. Now, I've had this panel connected. Now, there's other considerations, like this battery is really cold, it's really dead, and so on. So maybe we have to bring up some charge before it can even perform as the battery, but it's probably not going to be that much. So again, like I said, this battery was completely discharged last night. It's been -11 all night. The lights, nothing would come on when I turned the key. Now the solar panel's been connected for about 10 minutes, only 10 minutes, because I've been running back to my shed to get the voltmeter and new leads and so on. And now I'm going to crank the key. And I fully expect this thing to start. I fully expect this car to start. Okay, so here we go. Turn the key, dash lights come on. A little slow, but yeah, hey, started right up. Good. That's awesome. So what do we do now? Do we take the solar panel off and put it back in the shed, or do we leave it connected for a while? We leave it connected for a while, and I'll explain why. I just want to take a second to note what's on the back of this solar panel. So it says that the, what does it say? Open circuit voltage 21.85 volts, and short circuit current near around 6 amps. All right, let's head into the shed and do a little bit of analysis and see what's going on here. This curve right here, this line that goes down like this is the IV curve of the solar panel. So this is the characteristic current versus voltage relationship of the solar panel. And in this application, where we're not using a charge regulator, it's the battery itself that determines the voltage point at which we're operating on this IV curve. So when we have a fully discharged battery and we just connect the solar panel, we're going to be operating here. Let's say it's 10 volts. And as the battery charges up and increases the state of charge and the voltage comes up, we're going to drift along this part of the curve. And when the battery's full, near full condition, we're still going to be operating at the short circuit current, this because of the shape of the curve of close to 6 amps, which is what's happening out there now. So that's pretty interesting. Now, what's going to happen here is that for the majority of the time, the battery is going to be operating in this region, somewhere between 10 and 14 volts. But as the battery gets full, its voltage is going to drift up, and we're going to start to enter the gassing region of the voltage of the battery. And the battery is actually inherently voltage limiting itself. We won't be able to really get further than this point when we're connected to the battery, because all of the current, as the battery starts to get full, all of the current will go towards the gassing activity of the battery. Now let's think about how long we want to leave this battery connected. We talked about before where we needed about 40 seconds to be able to get enough current or enough charge into the battery to be able to start the car, which we saw. I mean, we had it connected for about 10 minutes and the car started no problem. But we also discussed that we still have a dead battery. And the starter battery, you know, in broad strokes, this might be able to store 30 to 50 amp hours of charge. And it's got to be pretty close to zero out there now. So let's say we want to fully charge this battery. That means at 5 amps, it's going to actually take us 10 hours to fully charge this battery to bring it up to a complete full state of charge. That's why I'm not particularly worried about leaving this battery connected out there. Ideally, I'd like to bring it all the way up to here for a certain amount of time, but I don't think I'm going to be able to get up to there with the amount of time that I have. Anyway, that's fine. Okay, it's been about an hour. It's still sunny, and we're going to try to start the car again and see if it feels any different. Dash lights light up, and it turns over like normal. So that's also a good sign. It means the battery is continuing to charge. So we'll shut this off, and we'll just keep charging. And I'm actually I got curious about what's gonna charge more now, the car or the solar panel. So what I'm gonna do is I'm gonna disconnect the battery and connect my current meter and actually see what provides more charge, the alternator or the solar panel at this point. Okay, so it turns out trying to measure the alternator current is a bit complicated because you have to start the car and then interrupt the circuit to put the current meter in series. Otherwise, you're going to blow the fuse in the current meter. In any case, I started the car like this with the terminal resting on. And then if I pull it off to break the circuit, then all the alternator charging current will actually go through the voltmeter itself. And we can see that it's charging at about 9 amps. Okay, it's been a few hours. It's starting to get cloudy outside. And maybe we've got about 20 amp hours back in this battery, 20 amp hours of charge back in this battery. So I'm going to try starting it again. Where's my keys? I'm going to try starting it again. There we go. Starts totally as normal. I think I'm going to put the solar panel away, and I'm going to drive to the city because now I have some things to do and I'm not going to be able to get this battery fully charged just on the sun. But let's review what we've learned. Learned you can start your car with a solar panel. You can boost start your car with a solar panel, and it doesn't need to be connected for that long. It only needs a few minutes to get a relatively small amount of energy into your battery that you can then use to start your car. That's point number one. Point number two, we can use any solar panel pretty much. We used a 36 cell, 22 volt open circuit solar panel in this case, but you could use a commodity 60 cell or a common 72 cell solar panel as well. They're a little bit bigger and they'll have short circuit currents that are probably at near 10 amps, but they will work just the same. And the reason is because we're using them in the left portion of the IV curve, and we're using them where that point in which they operate is defined by the battery voltage itself. So we don't need a charge regulator, we don't need anything, we just need a solar panel. Okay, so point one, doesn't take that long. Point two, we can use any solar panel. And point three is that we can actually do a detailed and complete conditioning charge on the battery. If we have enough sun and if we have enough time, we can fully recover and fully charge the battery, which is optimal for the battery health. In this case, I'm not going to be able to do that because it's got a little bit cloudy outside, and now I have somewhere that I have to go, which works anyway. And we also learned from this video that, at least in my car, the alternator charges at about 9 amps under these circumstances, or about 10 amps. So, you know, that is faster than the solar panel, but it's not like it's 100 amps or 50 amps, and it's not like it's going to charge. It's not like it's going to charge and fully recover the battery that much faster just running the car. So ultimately, you know, if I was to recover this battery, it's better just to keep the solar panel connected and recover it that way. And maybe tomorrow, I'll reattach the solar panel and put it on for a few more hours so the battery gets some more charge from the sun. And I can watch with my voltmeter. And once it comes up to 15 or 16 volts, I can leave it there maybe for an hour or so. And then, you know, carefully, not making any sparks on the terminal of the battery, carefully remove the solar panel. I can disconnect it at the connector on the solar panel, and then I'll have a fully recovered battery.